The Toba Caldera is a massive volcanic caldera located in North Sumatra, Indonesia, and is one of the largest volcanic structures on Earth. It was formed by the catastrophic Toba Supereruption that occurred approximately 74,000 years ago. Size and structure: the caldera measures about 100 kilometers long and 30 kilometers wide, making it one of the largest calderas in the world. It now contains Lake Toba, which is the largest volcanic lake on Earth. The supereruption, the Toba eruption, was one of the most powerful volcanic events in human history, classified as a VEI8, Volcanic Explosivity Index, event, the highest rating on the scale. It ejected an estimated 2,800 cubic kilometers of material, including volcanic ash, rock, and gases. Global impact: the eruption had severe global consequences, ejecting so much ash and sulfur dioxide into the atmosphere that it caused a volcanic winter lasting several years. Global temperatures dropped by 3 to 5 degrees Celsius, and some scientists theorize this event created a population bottleneck in early human populations. Current state: today, the caldera is a popular tourist destination in Indonesia. Lake Toba is a beautiful freshwater lake with Samosir Island in its center. The area is geologically active, with ongoing volcanic activity and hot springs. Scientific significance: Toba serves as a crucial case study for understanding supervolcanic eruptions and their potential global impacts, helping scientists prepare for future volcanic hazards. The Toba caldera actually consists of 4 overlapping volcanic craters formed by successive eruptions over the past 1.2 million years. The youngest and largest crater was created by the famous 74,000-year-ago eruption. The caldera sits atop a large magma chamber that's still active today, making it a closely monitored geological feature. Some scientists propose that the Toba eruption nearly caused human extinction, reducing the global population to as few as 3,000 to 10,000 individuals. This population bottleneck theory suggests that all modern humans descend from this small group of survivors. However, this theory remains debated, with some evidence suggesting human populations were more resilient than initially thought. Toba ash, called youngest Toba tuff, or YTT, has been found across vast distances, from the Arabian Sea to the South China Sea, covering an area of about 40 million square kilometers. These ash layers serve as important geological markers for dating other archaeological and geological sites across Asia. The caldera shows signs of ongoing volcanic unrest. Samosir Island and the Uluan Peninsula are actually resurgent domes, areas where magma pressure is slowly pushing the ground upward. Small earthquakes occur regularly, and there are numerous hot springs around the lake, indicating the magma chamber below remains active. Lake Toba reaches depths of up to 505 meters and contains unique endemic species that evolved in isolation after the caldera formed. The lake's chemistry is influenced by volcanic activity, with varying pH levels and mineral content. The Batak people have lived around Lake Toba for centuries, developing rich cultural traditions tied to the volcanic landscape. Their creation myths often reference the lake's formation, and they've adapted to living with ongoing volcanic activity. While another supereruption is considered unlikely in the near future, these events occur roughly every 300,000 to 600,000 years. Scientists continuously monitor Toba for signs of increased activity. Any future major eruption could have significant regional and potentially global impacts. Toba serves as a natural laboratory for studying supervolcanic systems. Researchers use it to understand magma chamber dynamics, eruption triggers, and the long-term impacts of massive volcanic events on climate and ecosystems. The Toba magma chamber is estimated to be enormous, potentially 50 to 60 kilometers long, 20 to 25 kilometers wide, and extending to depths of 15 plus kilometers. Modern studies using seismic tomography reveal a complex, partially molten system beneath the caldera. The magma is highly silicic, rich in silica, making it extremely explosive when it does erupt. The chamber likely operates as a multi-level system with different compositions at various depths. Beyond the famous 74,000-year-ago event, Toba has had multiple major eruptions. 1.2 million years ago, first major caldera-forming eruption. 840,000 years ago, second major eruption. 501,000 years ago, third major eruption creating the northern part of the current caldera. 74,000 years ago, the youngest and largest eruption. Each eruption was massive by normal volcanic standards, but the youngest was by far the largest. The 74,000-year eruption injected an estimated 6 billion tons of sulfur dioxide into the stratosphere. This created sulfuric acid aerosols that reflected sunlight back to space, causing global cooling. Ice core data from Greenland shows evidence of this cooling event. The volcanic winter may have lasted 6 to 10 years, with some cooling effects persisting for decades. Archaeological sites in India show a dramatic reduction in human artifacts in layers corresponding to the Toba eruption, supporting theories about population impacts. However, some sites in Africa show continuous human occupation through this period, suggesting populations may have been more resilient than initially thought. Indonesia's Center for Volcanology and Geological Hazard Mitigation maintains a comprehensive monitoring network around Toba, including seismometers to detect earthquakes, GPS stations measuring ground deformation, gas sensors monitoring volcanic emissions, thermal sensors tracking temperature changes, regular geological surveys. Toba ranks among the largest known eruptions in human history, comparable to Yellowstone's Lava Creek eruption, 640,000 years ago, Long Valley's eruption, 760,000 years ago, Campanian Ignimbrite eruption in Italy, 39,000 years ago. However, Toba's youngest eruption was significantly larger than most of these. Lake Toba is now one of Indonesia's premier tourist destinations, contributing significantly to North Sumatra's economy. The area attracts visitors for its natural beauty, cultural experiences with Batak communities, and geological significance. Tourism infrastructure continues to develop around the lake. Scientists are still investigating exact mechanisms that triggered the massive eruption, how quickly the magma chamber could refill for another major eruption, the precise global climate impacts and the duration, whether similar eruptions could be predicted in advance, the role of external triggers like earthquakes or climate changes. Toba sits within the Sunda Arc, a chain of volcanoes formed by the subduction of the Indo-Australian plate beneath the Eurasian plate. This tectonic setting provides the geological conditions necessary for such massive eruptions, with continuous magma generation from the subducting oceanic crust. Studies of Toba's volcanic products reveal complex magma mixing processes. The erupted material shows evidence of multiple magma sources combining, including both crustal melts and mantle-derived basaltic inputs. This creates a hybrid magma system that may be key to generating such massive eruptions. Zircon crystals within Toba rocks contain detailed records of temperature and chemical conditions, suggesting the magma chamber existed for hundreds of thousands of years before the major eruption. Lake Toba has unusual water chemistry influenced by volcanic input. The lake is slightly alkaline, pH 8.59.0, and contains elevated levels of dissolved silica, sodium, and other volcanic-derived elements. The lake stratifies seasonally, with distinct chemical layers that can trap volcanic gases released from the lake floor. Scientists use multiple methods to precisely date Toba deposits: radiocarbon dating of charcoal fragments, argon-argon dating of volcanic minerals, uranium-thorium dating of zircon crystals, paleomagnetic analysis of ash layers, correlation with ice core records. These techniques have refined the eruption date to 73,880 plus or minus 320 years ago. Researchers have proposed several potential triggers for the massive 74,000-year eruption: major earthquake along nearby fault systems, rapid influx of hot basaltic magma into the silicic chamber, critical volatile saturation in the magma, roof collapse of the magma chamber, external climatic factors affecting crustal stress. Some researchers investigate whether supervolcanic eruptions like Toba might be connected to global volcanic patterns or climate cycles. The timing of major eruptions sometimes correlates with periods of climate change or increased volcanic activity elsewhere, though causative relationships remain speculative. Thanks for watching. Like and subscribe, and don't forget to explore more geological wonders on our channel.